Okay. Michael,
welcome everyone. Welcome to the class today, and we'll be looking at some techniques to do dynamic presentations. Hopefully, right now you are seeing my Sketchpad screen, and that should be it. Is anyone hearing me?
Yeah, Michael. So everybody is muted.
Loud and clear. Okay, great.
Everyone's muted because.
Okay, we are. I just wanted to make sure that they were hearing me. As long as they're hearing me, we're great. So I can see the chat box going crazy already. So we're looking at dynamic presentations. We're going to look at a number of topics within this, and we're going to get in as much as we can today. And yet, on many of the initial ideas, I'll be giving you multiple examples of them. So we'll be running through a number of techniques a few times so that you'll catch on. But we're looking at presentation tools. We're going to start by looking at rotations, and rotations can be of fixed angle measures or of dynamic angle measures. Then we'll look at translations. Then we'll spend some time putting those together. And if we get a chance near the end of the hour, we'll look at Boolean Points, Boolean Constructions, and Tests. So let's get started. We're looking at fixed rotations or rotations of fixed angular measure. So for instance, here's a triangle, and we're simply doing rotations. In a few minutes you'll be doing these very easily. So if you notice what's going on, basically this is a rotation of 180 degrees and another rotation of 180 degrees about midpoints on the triangle. So let's do this. So all I've done here is created a triangle, and I'm going to construct the midpoints on this triangle. Now what I'd like to do is create a circle tool. Now we'll be using this type of circle tool repeatedly throughout all our rotation techniques. And I'm simply placing a point on the circle, and I'm going to rotate that point by 180 degrees. So I'm going to transform, rotate 180 degrees, because what I want really is not the circle but the 180 degree arc. So I'm hiding the circle and I have my arc of 180 degrees. I'm now going to put a point on that arc, and notice now that point is constrained to the arc. And I'm going to create my tools in order to make these rotations. It's really quite simple. So the first thing I'll do is mark the angle so you can see the technique I'm using. So I'm selecting my points so that I can mark this angle. And it might be beneficial for some of you if I give these values. So I'm going to select point Q, the center of the circle, and point R. I'm going to transform and mark the angle. So now that angle is in memory, whatever that measure is. I'm now going to select this midpoint as the center of rotation, and I'm going to select the entire triangle and go to transform, rotate by the marked angle. Now as angle Q center R goes to 0, my rotation goes to 0, and as the angle goes to 180, my rotation goes to 180. So now all I have to do is create an action button that will bring R to Q prime. So I select R and Q prime, and I go to Edit, Action Button, Movement. Now I have a movement button. I'll just go at medium speed. That's fine. But before I press that action button, I'm going to make another action button which brings R back to Q. And so now I have two action buttons. One brings R to Q prime, and the other one brings R back to Q. Now, I'm going to offset this just a little bit so that I don't get confused, because I'm going to make another point on this arc, and we'll label that point T. Now I'm going to mark angle Q center T. And now that angle is in memory. And I'd like to rotate the triangle on the other side. So I'm going to select that as the center of my triangle. And now make sure you do not select the triangle which is already rotated. Okay, we want the original triangle. And so I'm carefully coming in here and selecting the components that I want. And I'm going to go to Transform.
Michael?
Rotate. Yes.
Hi, Michael. This is Elizabeth. Sorry to interrupt. We're having a problem where every time you select something in the menu, the screen is going black. And I've never seen this in a webinar before. And I'm wondering if you might need to if maybe expanding your outer Sketchpad window would help, but every time you select a menu, the screen is going black, and a number of people have commented on it. Andres, I don't know if you're seeing that on your computer as well.
Okay, I'm going to try then to minimize my my meeting window, and then in doing that, how about if I share my entire screen?
Yeah, I did notice as well. I didn't quite put two and two together to realize it was when you were choosing menu commands. But yeah, it might be because you've chosen just to share that one window, which is weird. Which is weird why it wouldn't share the menu. That's usually considered part of that window.
Okay, are you seeing my Sketchpad window now?
I am.
Okay, great. Let's continue and let's see what happens. Okay. So now I have point T also, which was set as a marked angle. So now we want T to move to Q prime, and I'll make another action button. Is the screen staying clean now?
Yeah, it is.
Great.
That solved the problem. It's things are pretty small for your big screen, but it's better than not being able to see the menu.
Okay. Then I'm making T go to Q. So edit, action button, another movement button. And now I have these movement buttons which will perform what I want. Now I'm going to clean up my picture a little bit because I want to have the same angle marks in here as my original. And so I won't go through all the steps to make them exactly identical, in that I won't worry about the opacity right now. But notice what happens. Now the red and blue angles connect. And I'll come back here, and for the sake of preserving time, now we can see that red, blue, and green form a linear triplet, therefore 180 degrees. Now, if you want to make this into an actual demonstration, it's simply grabbing these action buttons in the order you want to run. So for instance, I want to rotate the triangle to the right and then rotate the triangle to the left. Edit, action button, and now this is a presentation because I have multiple action buttons going on. This is a presentation, and I want those to happen sequentially. So now I have a sequence of two actions. Now I want them to go home, so I'm going to rotate my triangles back, and that's happening sequentially also. And so I have these two buttons. Now, being the person I am, two buttons still is too many buttons. So I'm going to select sequence of two actions and sequence of two actions, and I'm actually going to create another action button, another presentation button. They will happen sequentially, and I'm going to put a 2-second delay in there. And I'm going to go one step further, and I'm going to call that button Run. Very creative. I'm now hiding these action buttons. I don't need those to show anymore. I'm hiding this tool. I don't need that to show anymore. And there are various components on the sketch that I can hide just to clean things up. And we get this process. Okay, so let's go to one that just is a little more attractive, a little more interesting. I have this, this square which has been cut in a particular way, and this is what we're going to do here in a second. We're going to rotate pieces of that square to make an equilateral triangle. It's an interesting theorem about equidecomposable polygons. Now that looks all that difficult, but it really isn't. If we recognize that that's a rotation of 180, another rotation of 180, and another rotation of 180, we're really all set. The only question is now positive and negative rotational angles. That's all. So if we come to our blank screen here, so all we have is the figure, and we want to start building our rotation tool. Well, in this case, again, we're going to start with a circle. This is the most common and useful technique. And I'm putting a point on the circle, and because all our rotations are going to be by 180 degrees, I'm selecting the center of the circle as the center of rotation, and I'm going to rotate that point by 180 degrees. And all I really want is the arc. So I'll hide the circle. So I have an arc of 180 degrees. Now notice in the demo that I just showed you a minute ago, I had the yellow quadrilateral rotate up in this direction. So it actually rotates by a positive angular measure. So I'm going to put a point here. And again, let me do this for your to help you out a little bit. We'll call that A, B, C, and let's make the center O. So now what I'm going to do is mark angle BOC. And if I double-click this hinge point here, and then select the components that I want to rotate, notice that I'm selecting the sides and the inside of that polygon. And I go to Transform, Rotate by the marked angle. Now as C rotates to A, that's what's going to happen. So I'm going to create an action button that does that. So edit action button movement. I'm going to have C move to A, and then I'm going to create another button that moves C back to B. And so now I already have buttons that do that. So we're on our way. Now what I'd like to do is rotate the blue and green polygons together. So I'm going to put another point here, and there are a number of techniques to rotate something by a negative angular measure, and I'll show you probably the easiest one. So for right now, let's call that point E, and I'm going to measure angle BOE. And I have 33.24 degrees. So now I'm going to go to number and calculate the negative of 33.24 degrees. And so now I have the negative angular measure, and that's what I'm going to rotate this figure by. So I'm going to double click on this top hinge point, and this time I'm going to select all the pieces that I want, and I'm going to transform, rotate, and now notice I'm selecting this negative angular measure over here. I hit rotate and angle. The angle's now moving. So that does what I want. So let's make that button so E goes to A, and then let's make E go back to B. So now this will happen. Now we can see the only thing I really have left to do is rotate this blue triangle into this gap, and I'd be all set. So I'm going to put another hinge point here at this intersection. And I'm going to use that hinge point. Well, that means I need another point on my rotation tool. So I'm going to put one more point on the rotation tool and name it F. Again, though, I'm still working clockwise. The rotation I want is clockwise, so I'm going to want to rotate by a negative angular measure again. So this time I'll again measure angle BOF this time, and then calculate the negative of angle BOF. And I'm going to double click this hinge point, select what I want to rotate, select that negative angular measure, and let's make our action button. So F is going to go to A, and then F is going to go to B. So now all of this will happen. Let's back these up. Now, at this point, what I would do is actually hide some of these figures. If, for instance, we were to hide this top triangle, and then hide this polygon, and then hide this triangle, and even hide this polygon. Then the tool will work well. Now let's just create our presentation button. We have all the action buttons we need. So I'm going to select move C to A, move E to A, and move F to A, and create a presentation button, which will happen sequentially. And then I want everything to go home. So I'm going to select move F to B, move E to B, and move C to B. I want that to happen sequentially, and then there are too many buttons, so I'm going to select sequence of 3 actions, the 2 buttons, and I'll create an action button which will make a presentation happen sequentially, and let's give it a 3-second delay. And now all of this can be hidden. We can rename this button Run. We can even hide the tools, and this is what we'll get. So I saw some comments in the chat that there are other ways to do this. Yes, there are countless other ways to do most of these techniques. I'm just running through a few to give you some ideas. Now, we're looking at the 30, 60, 90 right triangle theorem, and I've started some elements here on a sketch to help us out. So in this case, I've constructed a 30, 60, 90 triangle, and I know that the length of CB is 1/2 the length of the hypotenuse AB. How could we show that? Well, it's really quite easy. Notice I've already created a circle tool. I have one arc of 180 degrees, and I have a green arc of 60 degrees. So I'm going to put a point on the green arc of 60 degrees, and I'm going to measure, let's label that to help you out. That's point L. And I'm going to measure angle FDL. And again, I happen to know that I want to rotate clockwise, and so I'm simply going to do the negative of that angle. I'm going to double-click B, double-click B, select the segment and point C, and transform, rotate by the negative angle. And now we can see that this is going to happen. Okay, I'm going to leave it in that position right now and put a point on arc EF, point M on arc EF. And in this case, it really doesn't matter if I do a positive rotation or a negative rotation. So I'll do a positive rotation, and I'm marking angle ADM. And I'm going to double-click on the endpoint of that rotated segment, and I'm going to rotate by the marked angle. Now, let's just put our action buttons to work here. L is going to go to G, and L is going to go back to F. Then M is going to go to F, and M is going to return to E.
Hey, Michael, you have a whole lot of real estate. Is there any way you can do things? You're using you're using 5% of your space right now.
You know I can. You know I can. There we go. How's that? That makes it a little bit better.
A lot easier to see.
Thanks. Thanks for the reminder. I'm so used to just doing it and then cleaning it up later. Good reminder. Thank you. So now I can set up my presentation. And notice everything I've had so far is sequentially, but that's not always the case. So don't think that every presentation is sequential. It's not. And then I'm going to select these two buttons again, create another action button, and we'll give it a 2-second delay. And I can hide all my calculations or all my action buttons. I can hide my circle tool here. And what's going to happen is this. So segment BC rotates and then rotates on itself, showing that BC is 1/2 of AB. So once you do a few of those, let's look at the Euler segment here. So I've already created a triangle with its centroid, circumcenter, and orthocenter. And we know that those are collinear. They're on the Euler line. So the Euler ratio says that the distance from the circumcenter to the centroid is half the distance of from the centroid to the orthocenter. So we can see that this ratio always exists. Now, this is simply a rotation of 180 degrees and another rotation of 180 degrees, and we get a demo. We can see that they're not all that difficult. So let's look at dynamic rotations now. Notice all those rotations are fixed angle measures, 60 degrees, 90 degrees, 180 degrees. In this case, I start with an isosceles triangle, and I'm showing that the base angles are congruent. But notice this is dynamic. I can actually change the angles of the triangle, and this still works. So how is it reading that angular measure? And I've started some work here so you can see what's going on and how I do this. Firstly, I measure angle BAC, and it's currently 61.43 degrees, but you can see that that measure is dynamic. And so I want to create this rotation here, or this arc that will give me the correct rotation so angle BAC will fit in angle ACB. And it happens to be 180 minus angle BAC. So that's how I created this rotation. I simply selected a point. I did the calculation first. Then I selected a point and I rotated it about point D on this circle by this numeric measure. Well, now I have the arc that's not only the size I want, but the arc is dynamic. And you can see the arc actually changing as I change my triangle. So this is a dynamic rotation in that the angle is not fixed. The angle is dynamic based on the construction. So in this case, what I'm going to do is I'm going to, again, mark the angle. And I'm going to measure the angle. And I have 57.41 degrees for angle EDN. 57.41 degrees. Now, I want to create an angle over here. Notice I have this little line segment HI. The purpose for HI is just to keep things clean in my demonstration. So, for instance, I select HI and I'm selecting point A, and I construct a circle by center and radius. And I superimpose my line segments to the intersection of the circle, and that'll allow me to have a smaller angle to move, smaller as in the length of the segments, not as in the size of the angle. And that's what I'll be moving. So now I'm going to actually create, you'll see your first transformation or translation here, and then we'll be looking at translations in just a minute. So I'm going to put a point on segment AC, and I'm going to mark, let's label that O, and I'm going to select A and O, and I'm going to transform, and I'm going to mark that vector. Now, once I've marked that vector, I'm going to create the action button that O travels to C, and I'm going to create the action button that O travels to A. And that looks rather simplistic, but now recall I marked AO as a vector, and I'll do that again. Transform, mark vector. Now that vector's in memory. Now I can actually select these segments, and I can translate them by that vector. Now what I'd like to do is rotate that angle into this position. In order to do that, I'll actually be rotating by this 57.141 degrees, so we can see that it's dynamic based on angle EDN. So I'm going to double click on that center of rotation, and be careful that that center of rotation is this point, not that end point of the triangle. So I'm simply selecting my endpoints of my segments for right now, and I'm going to rotate by this measured angle, and this is what happens. As n moves, this is going to rotate into position. So to help you see what's going on, I'm going to hide these pieces. I'm going to move there. And so now that angle is going to move, and let's create our action button. N goes to F, and N goes to E. And I have my 4 action buttons. Now, in order to make this a little cleaner, work a little better, now I'm going to use the first sequence that's actually simultaneous instead of sequential. So I'm going to select move O to C and move N to F. And I'm going to make it simultaneous. Then I'm going to select N to E and O to A. And I'm going to make that simultaneous. Then I'll select these 2 action buttons, and I'm going to create a presentation, and I'm going to make that sequential, and let's give it a 2-second delay. So that's actually the only button I need, so I'm relabeling it Run, and I'm hiding everything that I don't need to show. So all I have is the Run button. And I would actually come in here and clean up my lines and those type of things. But I want you to see this work. So we can see that there's a rotation and a translation happening simultaneously. Okay, let's go on. Once you start getting the hang of these rotations, particularly the rotations by dynamic angles, you get some interesting opportunities. For instance, we know that angle ABC is an inscribed angle, therefore it's half the measure of the arc that it subtends. That means it's half the central angle. So angle ABC should fit into that central angle twice. And we can see that it does. And this is dynamic. So even as the angles are moving, they'll adjust if I change the angle ABC. So let's look at translations, and if we look at the exterior angles of a quadrilateral, we know that they sum to 360 degrees. Notice nothing's rotating here. They're simply translating from one point to another. So how do we do that? Well, I've started with a quadrilateral, and I've created the rays off the sides so that, and let me give you more real estate here, so that we can create the exterior angles. And I want it a little cleaner to create the exterior angles. So I'm using that segment up there and the points, and I'm going to construct my circle by center and radius, and then create all my external angles. So for instance, this will be an external angle, and here, and I'll mark these in a moment. I've created all my external angles. I can actually come in and hide my rays now. I'll hide my circles. And I've created my external angles. I'll come and mark these quickly. Now, for each of these, I'm actually going to create a point. So I have this point that is floating out in space, but I know what its destination is going to be. Let's call that O. And all of these points are going to be translated to O. So I'm going to mark the vector from A to this point that's going to move. And now I'm going to create the action button that makes it move. And then the button that makes it return. And I'll show you what's going to happen here. I'm translating it by the marked vector, and since that vector is moving, the angle is going to move with it. And so I can come in here and mark this angle, and this is what we get. And now if I created one of those vectors and moving points for each of the exterior angles, they will all go and merge onto this point O, and it'll show the 360 degrees. Okay? I think you have the idea of these translations, but we're going to do more anyway. So I just want to show you some nice ideas. Now this one is a translation followed by another translation. This is Paragel's puzzle, demonstration of the Pythagorean theorem. We can see all of these are simply translations. So there's no rotations going on whatsoever. If we wanted to replicate this, and we go to a blank screen, it's as simple as recognizing that the center of square of a squared can be translated to the center of c squared. So if I simply mark the vector and I create my action buttons, and then I have it return home, then already I'm able to do this. I can take that square, translate it by the vector, and since that point is moving, the square will move. So that would be my first move. My second move would be maybe to take the yellow polygon and from this vertice translate it to point B, and then maybe we'll take the blue polygon, and from this vertice translate to this external point, the green one. Notice I'm simply matching the right angles with their orientation here, and that's really all it takes. But now it would take a number of steps in order to do that. So let's combine translations and rotations a little more. So for instance, this is what we want to do in the next few minutes. We're looking at the mid-quad theorem. Mid-quad theorem states, given any quadrilateral, find the midpoints of the quadrilateral and connect those midpoints. That creates what's called the mid-quad. And the area of the mid-quad is 1/2 the area of the original quadrilateral. So we can see that the mid-quad of quadrilateral ABCD is indeed 1/2 the area of quadrilateral ABCD. And while this might look a little daunting at first, it really is quite amazingly easy. So, for instance, I'm starting with quadrilateral ABCD, and let me give you guys more real estate here. And notice I simply have created a circular tool, a rotation tool of 180 degrees. So I'm going to use that in a second. Matter of fact, let's create the action button right off. So R is going to go to K. And there's a movement button. And then R will go back to J. Notice that I do this very methodically. I always make the return button before I activate the first button. There are times your points will overlap another point and you'll get confused if you don't make the movement button and its return simultaneously or back to back. So now I can mark angle JIR. And I'm going to select the midpoint. I've already created the midpoint of the base of the triangle. And I'm going to rotate by the marked angle, so already I have this happening. So we're part of the way there. So I'm going to create another point on my circle. Point S, and I'm going to do the same thing. I'm going to mark angle JIS. I'm going to select this midpoint as the center of my rotation. I'm selecting the red triangle, and I'm going to rotate by the marked angle. And let's make our action button, so S goes to K. And S returns to J. So now I have half of my demonstration already created. I have the two rotations. Now I need to move my green and yellow triangles into position. And hopefully you can see that the green triangle actually fits down in this lower left corner and the yellow triangle fits up here. So, and it's simply a translation. So let's do that. I am going to put a point on this segment. I'm going to put it on this segment only to make it more visible, because the other segment is in this, this red region. It's harder to see. So I've made this point. Let's call it T, and I'm going to make the movement button that T goes to the midpoint of AB, and then I want T to return to the midpoint of BC. So now I'm going to mark the vector This is the critical component here. So I'm going to mark the vector from the midpoint of BC to T. So this is the vector, and I'm going to mark it. So now that it's marked, I can select the green triangle, and I can translate it by the marked vector, and now the green triangle is going to go into position. So let's do the same thing for the yellow triangle. So I'm going to put a point on the segment again, and that's point U. And I'm going to create a button that takes U to the midpoint of BC. And I'm going to create an action button that takes U to the midpoint of AB. And I'm going to mark this vector. Make sure you mark the vector from the vertice of the yellow triangle up to U. Then you can select a triangle. And now this is going to happen. So now all we have to do is arrange these into a presentation. And if you want things to happen simultaneously, that's fine. If you want things to happen sequentially, that's fine. And just to help you understand what's going on, we'll actually do it sequentially. So I'm selecting all the action buttons that will actually move it into position inside. And then I'm using the opposite order to move everything back outside. Then I have my sequence button, so that I'll connect with another action button, another presentation button. We'll have that happen sequentially, and let's give it a 3-second delay. And we hide everything we don't need. And this happens. Now notice this is dynamic, so I can change my quadrilateral and this still works. Okay? So hopefully you're seeing that creating the rotations and the translations, they're really not that difficult. It takes a little bit of practice. And then the connecting of the action buttons really isn't that difficult either. It's for most of you, you probably have the tools and the skill and the understanding to do all of this. You might never have seen it connected in this way before.
Hey, Michael?
Yes.
So let me just stop you for a second because you're presenting a huge amount of information that's going really quick, and I just feel like we need a moment to let it settle. But I appreciate the last thing you just said is that really all of the examples you've gone through so far share a certain similarity in terms of using the rotation and then doing translation and then having action buttons. I'm just responding verbally to a few different comments I've gotten in the last half hour. Again, for those of you who don't have prior experience with Sketchpad, this might seem completely overwhelming. I just recommend that there are many other things you can do to build your skills. First, some of you who have prior experience are still finding this hard to follow, and it is a tremendous amount of information that's being going through real quick. Just know that it is being recorded, and you'll be able to view it again. But I would also really recommend those of you that want to be able to do this proficiently to look into taking the 6-week online course that's all about this, because that gives you the time you really need to develop your own skills. This is more of just see what can be done, but it's not really intended something that you're going to be able to pick up just from a single viewing. And I'll leave it at that. I'm trying to see this.
Let me reiterate that point, because I think, Andres, you really made the critical point. We've only looked at three things. We've looked at translations, rotations, and then action buttons and how to put them together. And while it looks like a lot of information, it really is, when you get to see the video again, when you get to watch this class again, I think you'll see, oh, he's doing the same thing over and over. And it really, it's not that difficult. It's going quick. I purposely gone quick knowing that you'd have access, the class would have access to the recording, but it's, the techniques are really not that difficult.
And there's also been questions about step-by-step instructions. I think the easiest way for me to answer that is that's really, at this level, it's not so much the intent to provide people with step-by-step instructions of how to do this. I mean, Michael's gone through a number of examples that are similar, and we're more than help. You know, it's great for you to be able to build those skills, but we're not providing detailed step-by-step instructions here the way we would for an introductory course. Although there are actually specific detailed step-by-step instructions that are part of the online course if that's something you want to do. Okay, and there was two other quick comments. One was that people are asking about 4 versus 5. Most of the stuff Michael's doing works in Sketchpad 4, but you cannot take a Sketchpad 5 sketch and open it in Sketchpad 4. But you can always just download the 5 preview and open it up in there if you want to take a look at it. Again, 4 is over a decade old, and for us to survive, we need people to upgrade. I'm just saying it straight up. And the last thing on 5, there's some things Michael's been doing, like adding angle marks. Those are functionalities that are super easy in Sketchpad 5 that are actually major side detours when you're working in Sketchpad 4. You'd have to construct your own tools to do that, or go through and construct arcs and hide circles and all that. So there's some nice real benefits to 5 that I want to encourage people to look into if you are familiar with 4 already. Okay, having said that, Michael, you want to go on?
Sure. And notice that, again, this file that I've been working on tonight is available to you with all these demos already created, so you can if you're very bold, do a display show all, and you can see everything behind the scenes, but hopefully that won't freak you out too much. I'm going to go look at a couple ideas here. One of the things I wanted to do tonight is show you Boolean constructions, and so I'll do that. But here's a quick little demo showing that the altitude on a right triangle is the geometric mean, and our students have a lot of trouble with the whole idea of geometric mean. But again, that's already in your file. Looking at Boolean points, Boolean points are a very specific type of point. We do a lot with hide and show in Sketchpad. We can hide an element, show an element, but sometimes we don't want it to hide and show. We want it to exist or not exist. So take a look. I have line segment CE in this picture, and I have points DB. F is going to move to B, and then F moves back to D. Notice when F moves to B, it creates an intersection point that does not exist when F is in the D position. So that's a Boolean point. Now it exists, now it doesn't exist. It's not a hide and show. It exists at some point and it doesn't exist at some point. Having 5 minutes left, let me go through just a couple quick applications of these Boolean points. Constructing them is actually quite easy. And Andres, I don't know if at the end of this course you're going to promote the end of this webinar you promote the course a little bit. But in the new course that's coming out, you'll have a fairly detailed explanation of how to create Boolean points. But for instance, here's a situation where I can simply change my parameter, and notice what's happening is another point. I have points X, Y, Z, W, X, Y, Z. Those are distinct points at the same location. So that gives me a powerful technique to do something like this. Now I have Boolean point A, B, C, D. So those are 4 different points at the location. And points 1, 2, 3, 4, 5, which are, again, distinct points but at the same location. Now combining them, I have segment A1, segment A2, segment A3, A4, and 5, and B1, B2, 3, B3, B4, and 5. So I actually have 4 choices here, 5 choices here. I can now make 20 distinct line segments. And they are distinct. Now, what's an application? Well, this would be a simple application to this. So when I create the triangle, notice I'm using Boolean point 1. The square is on Boolean point 2, pentagon on point 3, and so forth. And those, notice at this point the triangle does not exist. The square does not exist. And at this point, the octagon and the heptagon do not exist. So because I can control the existence of that one point, I then can control everything that was constructed from that one point. Now we can actually create a tool in which I can change the attributes of a line segment. So I can do thick solid line segment, thick dashed line segment, thick dotted line segment. I can even change the color of that line segment and create using this tool. And basically what we have is 4 choices for the thickness and 3 choices for the attribute, solid, dashed, or dotted, and then 3 choices for color. We have a total of 36 possible line segments that are created. And we can see them running through these line segments, and notice it changes the color. And these are distinct line segments that I then can use in constructions. So let's look at Boolean Test. And for instance, what happens if I move point D into the figure? Well, now, because the measure from because these measures, the only measures that are being calculated right now is, here's the length AB is calculated. It's measuring the length of AD, it's measuring the length of BD and CD, and the length of from C to D is less than AB, but the other ones are not. And so it's simply testing these parameters. And after the test, when the test is positive, it dilates the particular circle by 1. When the test is negative, it's now dilating circle A by 0 and circle C by 0, so they're not visible. And now in this case, it's dilating circle C and circle B by 1 and circle A by 0, so it doesn't exist. So these are the power, this is the power of using Boolean tools, and we tend not to see this very often. Let's look at this example where, while it looks rather simplistic, that
Michael, I'm going to stop you.
Go ahead.
Michael, I think it's, honestly, what you've started in the last 5 minutes needs its own webinar. Let's do that. It's a huge amount of new stuff. The whole idea of a Boolean variable, it's either true or false, and that you can dilate by that factor so that it either shows up or doesn't show up, is the beginning of a giant intellectual realm that I think we need to cut it here. It's 5 o'clock, and already everything up until 5 minutes ago was amazing, somewhat overwhelming for some people, but really amazing. And I don't mean to cut you off, but I just feel like we're embarking now on an entire new realm that I think needs to be done in a separate hour. Sound good?
That's good. That's good because I was done anyway.
All right, great. Sorry. Yeah, because this stuff is fascinating, and honestly, the whole Boolean variable idea of a way to make things show or not show based on conditions is incredibly powerful and something that most people have very little experience with.
Right.
And I'm going to use that as a segue. So again, thank you for that presentation, Michael. I'm going to take the screen back here and just want to answer some questions that have come up. Let me see if I can do this correctly. Okay, so I think at this point, it doesn't look like my screen is showing. Oh, I haven't pressed show my screen. There we go. All right, so just want to say thank you for spending an hour with us this evening, for all of you that have been here. People are asking about what else they can do. I want to emphasize that we have online courses. If you go to keycurriculum.com and you go to training and then to online courses, you can see the courses that we offer and the start dates. The course that Michael has we've just finished the pilot of and will be offered for the first time in June. So you can see here the start dates are June 4th and July 2nd. So those are the summertime sessions. And Michael's course specifically is constructing dynamic demonstrations with Sketchpad. So that is, if you really want to get into what we did in the first 55 minutes plus have enough time to start getting into the stuff we just started touching at the end with Boolean variables and more, and have time to really internalize it, highly recommend taking this online course. As far as other webinars that we have webinars every Tuesday. Just take a look at our webinar schedule. You can see that the titles, for the Sketchpad webinars, in any case, will tell you. So, for example, June 5th, the first webinar of every month is always a beginning webinar. So if that seems more to your liking, that's another place to go. And then there is the Learning Center that comes with Sketchpad, which has step-by-step tutorials with embedded videos in it. Okay. I want to thank you all again for spending an hour with us today, and I want to thank Michael for a very informative and thought-provoking webinar. And Michael, is there anything else you'd like to say?
Just my pleasure, and this was fun on my end. I hope not too many people pulled hair out on their end.
Okay. So we'll leave the chat panel open for a couple of more minutes to answer any last questions. And thanks for joining us, and we hope to see you again soon. Good night.